Okay, so this is Unit 1, January 2025 paper. Okay, it's January 2025 paper. Question number 1 says, what is the total number of atoms in 8.8 grams of carbon dioxide? So to calculate the number of atoms, we have the formula that is number of atoms is equal to mole multiplied by Avogadro's number multiplied by the total atoms that are present in that formula. And the formula is carbon dioxide. Since we have three atoms in this formula, so mole is equal to mass over mr. So mass is 8.8, mr of CO2 is 44 multiplied by Avogadro's number, that is going to be this one, and multiplied by 3. Okay. So after calculating this one, so what's the answer? Can you tell me? Yes, what's the answer? Yes.
3.6 into 10 power 23.
Good. Okay. How many moles of ions are there in 40 cm cube of a solution of 0.05 mole per dm cube magnesium nitrate? So it means that first of all, we have to, again, I would say that you have to calculate the moles first, right? So, mole of magnesium nitrate. It's gonna be 40 divided by 1000 multiplied by the concentration. It would give you the number of moles of magnesium nitrate. What's the answer? What's the answer for moles? Yes, it's not very complex calculation. Tell me fast. Yes, Uriya, what's the answer?
2 into 10 power minus 3.
Minus 3 mole of magnesium nitrate, right? So
8
1 mole of magnesium, 8. It's 8, right? No?
minus 3.
2.8 10 to the power minus 3, right?
2 into 10 power minus 3. That's it.
Okay. Then 1 mole of magnesium nitrate can give 1 mole of magnesium ion and 2 moles of magnesium nitrate. Sorry, 2 moles of magnesium nitrate. So how many total ions I have? 3 ions. How many total ions I have? 3 ions. So for the 3 ions, you have to multiply this by 3. What's the answer? Answer should be C, isn't it? 2 into 3. Okay. It's supposed to be 0.006. Then for question 3, a water molecule containing the isotopes of hydrogen and oxygen, hydrogen 1 and oxygen 16 has a mass of this one. What is the mass of an atomic mass unit measured in grams? So for this question, we have to calculate the mass in AMU. Since they have given the masses in AMU, you have to take the exact reading, right? You have to take the exact reading. You can try by yourself, then I'm solving it. It's very easy. You can do. It's very easy. Yes. I'm only giving you 1 minute. Only 1 minute. Not more than 1 minute.
Sir, it's C.
It's C. So, okay. How did you calculate this one?
First, I calculate the combined mass. 2 into 1.0080 plus 15.995 give and then equals to 2.016. It gave me 18.
Okay,
Then we're gonna find the mass of our water molecules.
good.
So
Mass,
we're
mass
gonna
of water, mass of,
molecule.
okay,
Then 2.9908 into 10 power minus 23 divided by 18, which gave me 1.6 into 10 power minus 24. So that's the
okay,
mass of one atomic mass unit.
okay, okay. So what I did basically in water, so let's say I can say H2O is two times, it's two times 1 and 16, that is equal to 18. I'm talking about the molecular mass of water, right? This is the molecular mass, MR of water. Since the mass of water they have given to you, mass of water is already given, that is like that. Mass of water is already given, but in grams. Okay. So mass of an atomic mass unit measured in grams. So what I would be doing in this one, mass of like water, that is this one, divided by the molecular mass, total atomic mass units like that. Because you know what I did? It's equal to 16 approximately. It's equal to 1 approximately. So that's why I found this one. So when you would be dividing by 18, so you would be getting the answer in AMU because I'm taking the values in AMU. That's why. It's nothing, it's mass over MR. That's it. So that's why the answer is C. Okay. That's the that's the working of this question. And this is very easy question, of course. The percentage by mass of oxygen in this oxide is 69.57%. So, what can I say for this one? Percentage by mass of oxygen in this oxide, right? So we can find out the mass by taking the percentage. Since we know that percentage of anything is equal to is let's say the percentage of x is equal to the mass of x divided by the total MR of that compound multiplied by 100, isn't it? That's the formula. We used to say in sodium carbonate, I can say the mass of carbon is in the numerator divided by the denominator multiplied by the 100. That's what I can calculate the percentage of carbon in sodium carbonate. So the carbon is your subject, right? So let's say I have given that is 69.57. This is the percentage uh, oxygen. So what's the, of course, four oxygen atoms I have, 4O divided by the total MR. I don't know the MR, but I know that nitrogen is 14 in 2x, isn't it? It's 14x plus 4 into 16, that is 64 times 100 times 100. Can you like tell me the value for x? Can you tell me the value for x? Fast. Yes, 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 yes.
2.13.
Means approximately 2, isn't it? So nitrogen
Yeah.
is 2. So nitrogen is 2. It's supposed to be N2O4. So what's the molecular mass of this N2O4? It's gonna be 2 into 14 plus 4 into 16. So what's the answer? Yes, what's the answer? It's 16 fours are 64 and it's 28. Why are you taking so much time, man? Oh, ho, ho. So
92.
it's 92, yes. Four different solutions contain chloride ions. Three of the solutions contain the same number of moles of chloride ions. Which solution contains a different number? Four different solutions contain chloride ions. Okay. Four different solutions contain chloride ions. Okay. Or three of the solutions contain the same number of moles of chloride ions. Okay. Which solution contains a different number? This one, this one, this one, or this one? It's HCl, right? HCl is going to be like that. FeCl3 is going to be like that. Magnesium chloride is going to be like that. Sodium chloride is going to be like that, right? Sodium chloride is going to be like that. So basically this is the balanced chemical equation, right? So, and also now, what do you think? You have to calculate the moles as well, right? Like 15
Yes.
minus 3 times 0.8, then 10 minus 3 times 0.4, then 10 into 3 times 0.9, then 20 into minus 3 into 0.6 is going to be the moles of that particular compound, that is HCl. So what's the answer for the moles of HCl? Yes. Yes. Fast, 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 fast. Yes, Abdullah, fast, please. We have a short time and we have to complete this paper. Yes. I'm only asking this one and you're taking so much time. I don't know.
Sir, I'm calculating the answer for the first question, so I'm getting C.
I'm getting C. Okay. What's the answer for this one, by the way? Yes.
It's 0.012.
Okay. And what's the answer for second one? And of course, the mole ratio is 1:1 between HCl and Cl minus, so the answer would be the same for the chloride
For
ion as well.
for the
For
second
the
one, it's
second
also
one,
0.012.
0.012, and since the mole ratio is 1:3, right? Since the
Yes,
mole
sir.
ratio is 1:3, is gonna be 3 into 3 into 0.012. It would be equal to what?
1, 2.
0.036. So 3 ones are 3, 3 twos are 6, right? Okay.
And for the third one, it's 0.018 after including uh 2 multiplied by 2.
Okay. Zero. No, no, no. First of all, what's the answer for this? And then after multiplying by this by 2, yes.
So total answer I calculated for C was 10 into 10 power minus 3 into 0.9 into 2 equals to
Okay.
0.018.
Okay. And what's the
And
answer for the D?
for D I'm getting 0.012 again.
Oh, okay. So we have two different answers. This and this
And
is the
sir
same.
for the B
Yeah.
part
Okay.
include 3 को मल्टीप्लाई करने के बाद ही 0.012 आएगा.
Okay. 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 Good one. Good one. Good one. 3 into 3 is equal to 0. So of course the answer is C. Good. A solution contains 95 ppm of a solute. What mass of the solute is dissolved in 1 kg of this solution? ppm. You know ppm means what? ppm means what? Milligram per decimeter cube. You know, it's milligram per decimeter cube. It's called ppm. So basically mass of solute upon solvent. 10 to the power 3, 6. Okay. So
Sir, it's
we can
C.
C for cat.
Yes.
Okay. C. Okay. Let me calculate this one. So ppm is equal to, I can make it like it's solute. Okay. Solute and then divided by the solution 10 to the power 6. ppm is given, that is 95, and they're asking the mass of solute. It's gonna be solute and divided by the mass of solution. They are saying that it's 1 kg. It's going to be 1000 grams into 10 raised to the power 6. So you can calculate the mass of solute. That's gonna be C. Yes. So basically I'm telling you the method. You can opt this. What is the formula for this magnesium sulfate? 43% by mass of water. 43% by mass of water. So 43% by mass of water means what? This is a tricky question. Yes, should I tell you this one?
Yes,
Hmm?
sir.
Okay.
Yes, sir.
43% of water means that like this is means that it's a 43 grams. If you remember, when we used to solve empirical formulae, so we used to tell you that whenever the percentage is given in the question, so you can take the percentage as mass. So we took the same thing. We used to divide it by the MR to get the moles. Then we used to say, then we have to divide the number of moles by the least value to get the empirical formula. We are going to do the same thing. I'm going to take it as the mass of water. Okay. So this is the mass of water. Mass of water. So what would be the mass of magnesium sulfate? We can solve it easily. It should be like that, which is equal to 57 grams. 57 grams. And we can calculate the moles. Mole of magnesium sulfate. Then we can calculate the mole of water. So 57 over MR of magnesium sulfate and 43 over MR of water. What's the molecular mass of magnesium sulfate? Yes. 120.4. So I got the moles of magnesium sulfate, that is 0.47, and I got the moles of water, that is 2.39. What's the smaller number? 0.47. I'm going to divide it by the smallest number. So I'm getting 1 and this is going to be 5. So yes, this is going to be B, 5H2O. I'm getting 5 of water. So this is 5 water. It's just like empirical formula. The atom economy by the mass for the production of ethanoic acid. What's the formula for finding out the atom economy? So atom economy means that ethanoic acid, this is my subject. It's going to be 4 multiplied by the mass of the desired product, by the way, divided by the total mass of the reactant. Okay, so you can calculate it. Easy. It's easy. Or you can take the molecular mass of the product. So desired product is ethanoic acid. That is supposed to be 4 into the molecular mass of ethanoic acid. That is 61. No, 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 no. Ethanoic acid is this one, right? 12 plus 4 plus 32. What, what's the answer? 12 plus 4? 12, no, 24 because two carbons, right? 24 plus 4. What's the MR for ethanoic acid? Yes. Uh-huh. Yes. 61. 61 into 4.
Sir, 60.
60.
Yes, sir.
60 into 4 divided by the total mass of the product. Like I can say 60 plus 60 into 4 plus 2 into 18 multiplied by 100. What's the answer? What's the answer? Yes. Hmm? What's the answer? Are you calculating?
Yes, sir.
What's the answer?
Sir, 87%.
Okay. The first four ionization energies of the elements gallium, indium, germanium, and tin are shown. Which values are the first four ionization energies of gallium? Gallium, indium, germanium, and tin. We have to see the periodic table in which like group they are present or in a period. Okay. Let me see the periodic table. Gallium, indium, germanium, and tin. 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 Okay. Gallium, indium, germanium, and tin. You can see the periodic table. This is going to be the gallium. This is gallium, indium, and this is going to be germanium. And this is going to be tin. Across the period, ionization energy increases. Down the group, ionization energy decreases. It is higher, it is higher, it is higher, it is lower. The lowest one, the lowest one, the highest one. Down the group decreases and across the period increases, right? So, what can I say for this one? What values are the first four ionization energies of gallium? So, gallium means what? What can I say for gallium? This is the position of gallium, by the way. Yes. Can you take an idea? Gallium is this one. And after the gallium, we have germanium, right? So, and then we have indium, and then this is going to be tin. Let me show you the question. Yes. By the way, this is the first ionization. This is second. First. So gallium, let me write down the position. It was gallium, it was germanium, it was indium, and it was tin. So gallium, this is going to be for, I can say, this is going to be indium. You know, if I can see this one, this is going to be gallium, isn't it? Ionization energy is somehow higher. And if you can see 709, of course, it's across the period. It increases. So it's gonna for, I can say, this is for the germanium one, and this is for the tin one, isn't it? So of course, yes, the answer is B for ball. If you are thinking, how did you take an idea? Because I knew that ionization energy increases across the period, so they are higher than these two. So this is understood that this would be like that. But they are asking gallium. It's not like that. Gallium is not present in this column. It is present in the first column. So then I have to try these two. Gallium should be higher. Indium should be lower. This is higher. This is lower. That's why B for ball is correct. Simple. Yeah, it's a tricky question, I can say. Yep. Sulfur has a higher melting temperature than white phosphorus because sulfur exists in the form of S8. Which is a possible reason for this? Sulfur molecules have a greater permanent dipole than phosphorus molecule? No, 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 no. Both are non-polar, by the way. Both are non-polar. Both are having a temporary dipole. Okay, both are non-polar, right? So this is wrong. This is wrong. Both are non-polar, right? It's wrong. Permanent dipole, it's wrong. Sulfur has a stronger covalent bond than phosphorus. Covalent bond is covalent bond. It's not like a stronger or weaker. No, they are having the same strength. No, this is wrong. Sulfur has a giant covalent structure, and phosphorus has a simple molecular structure. Sulfur has a giant. Who said no? Oh, D is correct. Without checking, I can say D is correct. Of course, there is a one option that should be correct. All the three are wrong. Which species are arranged in order of increasing radius? Across the period, radius increases, sorry, decreases, and down the group, radius decreases. Okay. And I can say cations is smaller than anion. Down the group, size increases. Across the period, size decreases. Okay. So, increasing order, increasing radius. So it should be in order of increasing radius, right? So what do you think? Let me check A. Let me check A. It's larger than chloride. It's good. Yes, it's correct because the positions are like that. So this is correct. This is wrong. Okay. No, this is correct. Okay, because this is cation. It's higher. And cations are lower than the are like the normal one. So this is wrong. Okay. And anions are larger than argon simple atom. Yeah, this is also correct. And yeah, A is correct, isn't it? Isn't it? It's following the statement. Anion is greater than this one. Both are anions. Then we have to see the position of these two elements in the periodic table. So I saw that they both are present in group 7. Down the group size increases. Size increases, yes. So bromine is lower than chlorine. Okay. And the size of anion is generally larger than the normal atom element, normal neutral element. And the neutral element is higher than the cation. Cation is the smaller one. That's why this is correct. Okay. Which cation would be the most polarizing? Most polarizing means it should be smaller and the charge should be larger. Straight away, this is small and large. It should be A. Straight away. It's a concept basically. Okay. Which of the resulting molecules does not have a permanent dipole? The two axial chlorine atoms are replaced before the three equatorial atoms. Which of the resulting molecules does not have a permanent dipole? Yes. Yes. Let's say I'm going to write fluorine and fluorine. So then what would you say? They are non-polar. They are non-polar, right? Because this is going to be the trigonal planar, isn't it? So yes, this is supposed to be doesn't have a permanent dipole. They're going to cancel each other. They are going to have a symmetry, isn't it? They are going to have a symmetry. So we have to see the symmetry as well. This is mandatory because let's say in carbon dioxide, this is a symmetrical structure. This is a symmetrical structure, right? So for a symmetrical structure, I can say like this is like the dipoles are going to cancel each other. When the dipoles are going to cancel each other, so yes, I can say this is going to be non-polar. Like it wouldn't be having a permanent dipole because polar has a permanent dipole, by the way. You need to memorize these things, of course. You know, hexane is organic solvent. It catches fire, isn't it? It catches fire. It's supposed to be A for apple. IUPAC name, okay. First of all, I'm supposed to select the long carbon chain, longest carbon chain. This is the branch 1, 2, 3, 4. 3, 4 is only B. It's very easy. It's only B, isn't it? So, okay. Overall, this is overall, I was saying that this paper is very easy. Okay. And it is. You can do this.